What would happen if a single microscopic change in the past completely erased the world you currently know? In 1963, meteorologist Edward Lorenz was running early computer models to simulate atmospheric convection. He discovered that a tiny rounding error, a change as small as the air displaced by a butterfly's wings, caused his long-term forecast to diverge until it no longer matched the reality of the simulation. This chart shows the sensitivity Lorenz encountered. Even an infinitesimal shift in step size triggers wildly different final values. By framing all three scales, we see chaotic fluctuation persists across time. Any initial variance expands until it dominates the outcome. Applied to human reality, stepping on a single insect or moving a pebble reorders the causal sequence of the future. The chain of events is completely scrambled. Because of this exponential divergence, the physics of the system makes long-term predictability impossible. The math simply fails. But what happens if we attempt to use this volatility? What if humanity weaponized this fragility by building a time machine? If a wing beat can rewrite the weather, then a person traveling to the past would create a chain of events so divergent that the original history could no longer exist. Moving backward in time creates a fundamental conflict. It breaks the physical laws of cause and effect that govern the universe. This flowchart illustrates the grandfather paradox. A traveler moves back in time and kills their own ancestor. By doing this, they remove their own birth from history. They could never build a machine to travel back, leaving the timeline in causal breakdown. We also face the bootstrap paradox, where information or objects exist in a loop with no origin point. Consider this Shakespeare folio. If a traveler takes a modern copy of these plays to the past and gives them to William Shakespeare to publish, the plays are never actually written. They simply exist, uncreated by any mind. These loops introduce mathematical contradictions that the physics of cause and effect cannot reconcile. To avoid these logical dead ends, physics suggests the universe possesses structural defense mechanisms that resist the presence of a traveler. The first defense is a topological fracture. The mere gravitational pull of a traveler entering a wormhole causes the space-time tunnel to destabilize. The wormhole physically fractures before the traveler can arrive. This fracture forces reality to split into many worlds, isolating the paradox in a parallel timeline to keep the original history intact. If the wormhole holds, the universe deploys the thermodynamic burn. A macroscopic object moving backward violates the thermodynamic time arrow, which requires entropy to increase. As shown in this diagram, the radiation inside the wormhole destroys the process. The spaceman is annihilated by an anti-cloud upon arrival, ensuring they are destroyed before they can interact with the past. Reality protects itself by ensuring that backward travel for a complex being is physically lethal. But what happens if something smaller, like a pulse of information, survives the journey? The Novikov self-consistency principle suggests that quantum mechanics provides a stationary solution to paradoxes, preventing them before they start. This heat map shows a quantum simulation of a time traveler signal sent backward. Initially, the wave expands cleanly as it heads into the past to suppress its younger self. But the final result shows that the signal cannot disappear. Instead, it creates these dense interference patterns, resulting in self-amplification. The math proves that complete suppression of the past is impossible. The chaotic system is forced to converge into a stationary, self-consistent equilibrium. The timeline adjusts itself to ensure the future remains exactly as it was. The universe forces chaotic free will to bend around a predestined outcome. We are left with a cosmic contradiction. The forward timeline is fragile, but the backward timeline is perfectly rigid. Any attempt to change history was already factored in to the version of history you currently remember. The loop is already closed, which leaves us to wonder, if you did manage to change the past, would you still exist to remember it?